Your brain cannot hold infinity, and yet you believed in it by age 5. Not because anyone taught you, not because you could see it, you formed that belief by learning a pattern you could not stop applying. And that pattern lives in your brain as a repeating motion that never completes. Your visual system trying to move rightward toward a boundary that keeps moving with you. The moment you stop trying to picture infinity, that motion stops. The moment you think about thinking about it, the discomfort returns. That loop you're experiencing right now, where you're trying to imagine yourself trying to imagine forever, that's the thing your brain built to model something it cannot model. And the strain is not a sign that infinity is too abstract. The strain is a sign that your brain is trying to speak a language it was never designed to use, using muscles that were designed for something else entirely. I came across this problem while reading about how children learn to count. A completely separate question, or so I thought. I was looking at research on 5-year-olds, and something made me stop. These kids were being asked simple things. Can you always add one more number? Most of them said yes. Does number ever end, or does it go on forever? Most said forever. And I thought I understood what was happening. They memorized the pattern of the count list. They knew that after 9 comes 10, and the pattern repeats. Simple enough. But then I kept reading, and the researchers asked the same children about space. Does space ever end, or does it go on forever? And about time, does time ever end, or does it go on forever? And something stopped making sense. The children gave almost identical answers across all 3 domains. They believed in infinity for number the same way they believed in infinity for space and time. The pattern they learned in counting had somehow generalized. But that's not how learning usually works. You learn to count numbers. You don't learn to imagine infinite space by counting. And yet, they did. I'm still not certain I fully understand what that means. But I think it's because they were learning something much deeper than a counting pattern. They were learning how to model the concept of no boundary at all. Here's what I want to explore with you. Not how children learn this, but what actually happens inside your brain when you try to hold this concept. Because the experience is strange in a way that most descriptions of infinity skip over entirely. Most explanations tell you about what infinity is mathematically. They tell you it's larger than any number you can name. They tell you the universe might be infinite. These explanations treat infinity like information you're supposed to absorb. But infinity doesn't feel like information when you actually try to think about it. It feels like a process that won't settle. It feels like something your brain is doing rather than something your brain is understanding. And the difference between those two things is everything. Your brain has a system for understanding space. It's ancient. It evolved so you could move around, find food, avoid predators, understand where your hand is in relation to your body. This system lives primarily in your parietal cortex along the intraparietal sulcus. It's one of the most evolutionarily conservative pieces of your brain, which means it's almost identical across humans and has barely changed in millions of years. That system is extraordinarily good at one thing: understanding bounded space. Space that has edges. Space that has limits. Your parietal cortex can track objects moving toward a boundary. It can predict where they'll stop. It can represent there versus here with stunning precision. But that precision comes with a built-in limitation. The system assumes there's always a boundary. It assumes space ends somewhere. Now, you also have a motor system, muscles and the circuits that control them. When you think about space, your motor system doesn't stay quiet. It activates, not because you're actually moving, but because thinking about space involves simulating movement. Neuroscientists call this motor simulation. When you imagine reaching for something, the motor cortex that would actually move your arm lights up. When you imagine a line extending rightward, the circuits that control rightward movement activate. This isn't poetic or metaphorical. This is measurable in brain imaging. The same neurons that fire when you move, fire when you think about movement. Your brain doesn't really separate imagination from simulation. It treats them as the same process. Now combine those two systems, you have a spatial system built for bounded space. You have a motor system that simulates movement toward boundaries. And now you're trying to imagine space that has no boundary. So your brain does the only thing it can do. It simulates movement toward a boundary. And then, because there's no boundary, it resets and simulates movement toward the next boundary, and then the next, and then the next. It's iterative. It repeats. And here's the crucial part. It never completes. Every time you reach what you think might be the edge of space, your brain recognizes there could be space beyond that edge. So it moves again and again. The motion never settles into a stable representation. It can't. By definition, infinity can't be represented as a stable thing in your brain because representation requires boundaries. This is where the discomfort comes from. Not from the abstract concept, not from the mathematical difficulty. The discomfort comes from your motor system being asked to complete a motion that by definition cannot complete. It's like asking your hands to reach the end of a line that has no end. Your hands will keep moving, but they'll never arrive. Your brain knows this is happening. And that knowledge creates a very specific kind of strain. I realize I said motion that never completes, and I should be more precise here. What I mean is that the iterative process never reaches a final state. Each iteration reveals a new iteration beneath it. You try to imagine the edge of space, and you recognize that beyond that edge, there could be more space. You try to imagine a number so large that nothing could be larger, and you recognize that you could add 1 to it. You try to imagine a span of time so long that it never ends, and you recognize that the next moment could always come. The motion continues. The boundary recedes. That recession is the feeling. That's what you're experiencing when you feel the discomfort of infinity. You're feeling your brain trying to move toward a destination it will never reach. Different neuroscientists describe this differently depending on which parts of the brain they're studying. Some focus on the parietal cortex and the spatial systems. They talk about magnitude processing, how the brain represents quantities. Others focus on the prefrontal cortex, which handles abstract reasoning. The prefrontal cortex is what lets you think about things you can't see. It's what separates humans from most other animals. It's also the region that lights up when you try to engage with abstract concepts like infinity. But here's what's important. The prefrontal cortex doesn't replace the spatial system when you think about infinity. It recruits it. It conscripts the ancient motion-based, boundary-seeking spatial system to help you think about something that has no boundary. And that recruitment creates a conflict. You're using tools designed for one job to do a fundamentally different job. Think about what happens when you try to picture the number 1 million. Your brain doesn't actually generate an image of 1,000,000 somethings. That would be impossible. Instead, your brain activates the number line system. On this mental number line, small numbers are on the left and large numbers are on the right. Your attention shifts rightward toward larger numbers. And the further right it goes, the more activation occurs in the regions that process spatial magnitude. 1 million is very far right. So your brain generates a sense of very far along the number line. But the number line is still bounded in your mind. You can imagine reaching the end of the number line, or at least some large number that feels like an end. Now remove that boundary. Try to imagine a number so large that you could never conceive of a largest number. Your brain still activates the number line. Your attention still shifts rightward, but now there's no endpoint. The rightward shift has nowhere to land. So your brain keeps shifting, keeps moving, keeps trying to find the edge that you've now told it doesn't exist. That's the loop. That's what you're feeling when you sit with the concept of infinity for more than a few seconds. The strange thing is that this doesn't mean your brain is failing at something. It's not. Your brain is actually succeeding at something quite remarkable. It's generating the most accurate representation of infinity that a finite brain can generate, a process that never completes, a motion that never settles, a boundary that recedes forever. In a sense, that repeating, never settling motion is the closest your brain can get to actually holding the concept of infinity. Not as a thing, as a process, as a way of moving. Children figure this out before they can articulate it. By age 5 or 6, most children in studies have formed some belief about infinity. They believe you can always add one more number. They believe space might go on forever. They believe time might never end. And here's what's remarkable. They formed these beliefs not by being taught infinity, but by learning the structure of counting. Counting is a pattern where the next element is always generated from the previous one. 1 becomes 2 because you apply the successor rule. 2 becomes 3 by applying the same rule. There is no deepest level to the pattern. You can always go one level deeper. You can always apply the rule again. Children learn this through repetition and correction. Adults teach them after 9 comes 10. After 19, comes 20, the pattern continues. And at some point, children's brains extract the rule. They see that the rule has no endpoint, and suddenly they believe in infinity. Not because they can imagine it, but because they can imagine the process of applying the rule endlessly. They can simulate the motion of counting up, up, up with no final destination. They've built a model of infinity inside their brains using the same iterative motion that your parietal cortex and motor system are trying to do right. Now, as you think about this, what's interesting is that children don't all arrive at this belief in the same way. Some children believe you can always add one more number, but don't believe numbers ever end. Some believe numbers end, but still think you can keep adding. The beliefs are inconsistent in ways that suggest different parts of the brain are operating. The iterative rule application system is separate from the endlessness intuition. One is a process. One is a property. Your brain can believe in one without fully believing in the other, and that inconsistency doesn't go away as you get older. Even mathematicians, people who have spent decades thinking about infinity formally, report feeling this discomfort. They've learned to work with infinity mathematically. They can prove theorems about infinite sets, but the intuitive discomfort often remains. The feeling that something about infinity doesn't quite fit into the categories your brain uses to understand the world. This is because infinity breaks something fundamental about how your brain represents concepts. Your brain represents most things as bounded entities. A dog is a bounded thing. It has edges. A number has boundaries. It's discrete, countable, finite. A moment in time has edges. Even abstract concepts like justice or love are bounded in your brain. They have characteristics that define their edges, but infinity has no edges. It has no defining characteristics that would allow your brain to draw a boundary around it. So your brain can represent it the normal way. Instead, it does something stranger. It represents the process of trying to represent it. It generates the iterative motion. It holds the loop. There's a metaphor that shows up sometimes in neuroscience papers about embodied cognition. The idea that understanding is built on physical simulation. When you understand that a ball is rolling, your motor system simulates the rolling. When you understand that a line extends rightward, your attention system simulates the rightward movement. Understanding isn't separate from these simulations. It is these simulations. Your brain thinks in motion, in space, in the language of the body. And infinity challenges this because infinity is not a motion that can be completed. It's not a space that can be crossed. So your brain can only understand it by representing the endless attempt to complete it. The endless simulation of the crossing that never arrives. You don't understand infinity by holding a picture of it in your mind. You understand infinity by feeling your brain doing this work. What makes this even stranger is that your brain does have some regions specialized for abstract thought. The prefrontal cortex, particularly the rostrolateral prefrontal cortex, can engage with ideas that have no physical referent. It can think about justice or meaning or hypothetical scenarios. But even these abstract thought regions don't work in isolation. They work by recruiting the more concrete systems. When you think about justice, you activate regions involved in social understanding. When you think about hypothetical futures, you activate regions involved in memory and imagination. The brain doesn't have a separate abstract thought mode. It has abstract thought by repurposing concrete systems and using them in new ways. And with infinity, that repurposing creates friction. You're using spatial and motor systems designed to navigate a bounded world, to think about something unbounded. The systems work. They do generate something, but what they generate is a process, not a product. A never-settling motion instead of a stable concept. Now, there's something I should correct about what I said earlier. I described infinity as a motion that never completes, but actually that's not quite right in the mathematical sense. Infinity isn't a number you're trying to reach. It's the property of never reaching any final number. Infinity is the endless structure itself, not a destination within that structure. Your brain can't quite grasp this distinction because it's used to thinking in terms of destinations. Your brain asks, is there a point called infinity that I'm approaching? And the answer is no, but you're approaching the property of having no final point. That gap between the question your brain wants to ask and the answer it actually gets, that's another source of the discomfort. Your brain is asking a question that has no answer in the framework of the question itself. I think this is why infinity causes the specific kind of unease that it does. Not the unease of something being difficult or complex, but the unease of a question your brain is structured to answer being answered in a way your brain isn't structured to understand. It's like asking, where does the left end? The question assumes there is a left edge. When you're told there is no left edge, your brain doesn't update the question. It tries to ask the same question again, but differently. Where does the limit go? Is there a limit to how far the limit recedes? And on and on. The question echoes. The answer keeps shifting the ground beneath the question. There's a famous thought experiment that shows this. Ask yourself, what's the smallest number greater than 0? Your brain immediately tries to answer 1/10th, 100th, 1/millionth, and immediately you recognize you can always find a smaller number. The motion begins. The boundary recedes. You're doing it right now. Your brain is trying to find a stopping point and recognizing there is none. That recognition is the discomfort. That's your brain bumping against its own limitations. Here's where it gets deeper though. This limitation isn't really a limitation of your brain. It's a limitation of finite systems trying to represent infinite ones. A finite brain cannot generate an infinite process. It can only generate a process that it recognizes as never ending. It can simulate the beginning of something that never ends, but it can't simulate the whole thing because the whole thing is infinitely long. So what your brain does instead is generate a recognizable pattern and then recognize that the pattern has no endpoint. That's actually quite clever. It's your brain's way of working around its own finiteness. It can't hold infinity in its working memory, but it can hold a representation of something that never terminates. It can hold the structure of endlessness even if it can't hold the endlessness itself. This might be why children develop these beliefs about infinity so early. It's not that they're taught infinity, it's that they learn the structure of counting and their brains automatically extract the property of no final member. They learn the pattern, they extend it, and they recognize it extends forever. The belief is almost inevitable once the pattern is learned. It's not a conclusion they reach through reasoning. It's a recognition that emerges from the structure of the pattern itself. But here's what I think is the most important part of this, and what I didn't expect when I started looking into it. The discomfort you feel with infinity isn't a sign that your brain is broken or limited in some bad way. It's a sign that your brain is doing something quite remarkable. It's taking a system designed for one purpose, navigating bounded space, tracking finite quantities, completing finite actions, and using it to represent something fundamentally different. The strain is the price of that repurposing. And the fact that you can do it at all, that your finite brain can generate a representation of something infinite, is actually one of the more remarkable things your brain does. Most animals can do this. They can understand boundaries, they can understand large quantities, but they can't understand unbounded quantities. They can't hold the concept of infinity. Your brain can. It does it by using the only tool it has, spatial and motor simulation. And it creates a repeating, never settling process as a way of representing something that never settles. That's not a failure, that's a solution. So when you feel that discomfort, when you try to imagine infinity and feel your brain kind of looping back on itself, unable to settle into a stable thought, that's not confusion. That's your brain working exactly as designed, but in a way it was never evolutionarily designed to work. You're using ancient spatial machinery to think about something that has no space. You're using a system built for boundaries to think about something that has no boundaries. The fact that you can do this at all, that you can hold this loop in your mind, is evidence of something quite powerful. The ability to think beyond the constraints you were given. The question that lingers though, and the one I'm still sitting with, is whether there's a limit to how far this can go. Your brain can hold the concept of infinity because it can hold the structure of an endless pattern. But what about infinities beyond that? What about the infinity of all possible infinities? What about infinities that don't even have a describable pattern? Can your brain go there? And if it can't, is that a limit of the brain or a limit of what it means to understand at all? I think the honest answer is probably somewhere in the middle. But I also think the answer doesn't matter as much as the fact that you can feel your brain trying, that you can sense the limit forming even as you reach towards something beyond it. That discomfort is real, it's useful. It's your brain telling you something true about what you are. Finite, bounded, limited in certain ways, and yet capable of reaching toward the unbounded, capable of holding a thought about something that has no end, capable of feeling your own finiteness while thinking about infinity. That capacity is rare, That capacity is the thing that makes you capable of mathematics, of philosophy, of asking questions that have no simple answers. The discomfort is part of what enables it.